talked about the Grignard reagents. And with the Grignard reagents, that it's versatile. You can make Grignard reagents from alkyl halide, from aryl halide, from vinyl halide. That means that R can be alkyl group, or it can be a vinyl group, or it can be aromatic ring. So any of these methods would work as long as you have them. You have the halide attached to this carbon. So you can start with any of these and make the Grignard reagent. And X can be bromine, iodine, or chlorine. Either one of them would work. Diethyl ether is used as a solvent, and often students, they make a mistake. They think that this is one of the reactants, or Grignard is being attached or attacked to the diethyl ether. Please make sure that if you see this, it's necessary to use ethyl or diethyl ether as the solvent, because if you use any protic solvent, a protic solvent is going to react with Grignard reagent, and it will destroy the Grignard reagent. So what's going to happen if you add protic solvent to this? Let's say you add water, it's going to change to RH, that's alkane, and it will give you MgXOH as a precipitate. Alkane is not something that is going to attack the next group or the carbonyl group, and this is MgXOH is going to be a precipitate, so you're not going to get a product. So it's very important to use an aprotic polar solvent. Why does it have to be polar? Is that ether has pair of unshared electron on oxygen. Why are you using ether? With that, you don't use like hexane, or you don't use methylene chloride, because Grignard reagent is very reactive, and it is important for Grignard reagent to be stabilized. So if you bring ether is going to surround the Grignard reagent from oxygen side. So basically, the plus charge in the Grignard reagent is going to be stabilized by ether. So we use diethyl ether as the stabilizing solvent. You cannot use protic like alcohol or water as the solvent. Neither SH like thiol cannot be used as a solvent. Water, alcohol, or SH cannot be used when you have Grignard reagent until the Grignard reagent reacts. It finishes the first step of the reaction, and the second step, you will get that destroyed. You add water, you protonate, or you hydrolyze. You add water, and you would destroy the leftover of Grignard reagent. Other examples of organometallic compound or reagents, they are alkyl lithium. For alkyl lithium also, you would add the alkyl halide, vinyl halide, or aryl halide to lithium, and you get your alkyl lithium as the reagent. The property of alkyl lithium also is similar to Grignard, because you have a plus charge on lithium, minus charge on the alkyl group, and that makes the group or the alkyl group here a strong nucleophile. So when you do have a strong nucleophile, then it can attack the partially positive carbon that's coming from carbonyl group or from alkyl halide. If this happens, if nucleophile attacks the alkyl halide, leaving group would leave, the halide would leave as a leaving group. If nucleophile attacks the carbonyl group, the pi bond breaks over the oxygen. So it's just the pi bond that is breaking, is not leaving. So when the nucleophile from organometallic, which could be the alkyl lithium or the Grignard reagent, attacks the carbonyl group, the pi bond will break over the oxygen, you get alkoxide. So alkoxide is intermediate. You cannot leave your reaction in this step. So every time you're using Grignard reagent or alkyl lithium or RLI, you must follow up by the second step, which is the hydrolysis. So you cannot isolate. Alkoxide is very reactive and is still mixed with the organometallic compound. But when you hydrolyze the alkoxide, basically you protonate the oxygen, the alkoxide would change to alcohol functional group. At the same time, if there is any leftover of the reagent, is going to be destroyed or react with water, and it would be safe for the reaction. So it kind of stops the reaction also. That's the last step. Do not forget to hydrolyze, followed by adding the Grignard. Now, what you need to memorize in this chapter, just to make sure that you are doing that for the final exam, is if you're adding Grignard to formaldehyde. Okay, so Grignard plus formaldehyde, make a table for yourself. Grignard plus formaldehyde would give you primary alcohol with addition of 1 carbon. So if your Grignard has 2 carbon, the alcohol is going to end up with 3 carbon. Okay, so the mechanism is all the same, because we already talked about the mechanism. The nucleophile is going to attack the carbonyl group. The pi bond will break over the oxygen. You get the alkoxide. You hydrolyze that to protonate the alkoxide, and you get the alcohol. So that's the mechanism. It's the same if you're adding formaldehyde, aldehyde, or ketone. But you also need to know that if you use Grignard with formaldehyde, you would get primary alcohol, first of all, with addition of 1 carbon. So your 2 carbon, you have 2 carbon here, you end up with 3 carbon. There's an example here, you start with 1, 2, 3, 4 carbon, the product should show 5 carbon. So that's, so you have 5 carbon, so you have a pentanol, here you have butyl, okay? Addition of 1 carbon. And remember, ether is solvent. And when you are separating your reagents by steps 1, 2, what does it mean? It means that first you're adding ether to this Grignard reagent to form. Then on the next step, you are going to hydrolyze it. You cannot add water, ether at the same time, because as soon as you add the water, the Grignard is going to react with water rather than reacting with the carbonyl group, and it's going to destroy the Grignard. It would change to alkane and is not going to work. So on the next step, or the second type of reactions or carbonyl group, as a choice, you can use aldehyde. When you say aldehyde, you have one of the groups attached to carbonyl group is R group, and the other one is hydrogen. The mechanism again is going to be the same. Recording. Okay, so if you have aldehyde, that means your aldehyde is going to have more than 1 carbon. That's the difference between formaldehyde and aldehyde. Formaldehyde has only 1 carbon, but aldehyde has more than 1 carbon. So when this happens, as the mechanism is going to be the same, the Grignard is going to attack the carbonyl group. The pi bond breaks over the oxygen, and after you protonate or hydrolyze it, it will change to alcohol. The difference is if you are using aldehyde, the alcohol that is going to be prepared is going to be secondary alcohol. So we want to make sure that we make a note of that. If Grignard is added to aldehyde, you get secondary alcohol. For formaldehyde, you get a primary alcohol. Now, if you have 2 carbon from the Grignard, it depends on how many carbons you had from the aldehyde. It's not limited to 2. It could be as many carbon that you choose. And then you are going to see that on the product, you will see 4 carbon. It's going to be a challenging day. The formaldehyde, you have 2 carbon from the from Grignard and 2 carbon from the aldehyde. That gives you 4 carbon alcohol. What you notice, because you already took the quiz for this, and is that the carbon that used to carry the CO double bond now carries the OH. So that is the main thing. So the new bond is forming between a carbon from Grignard and the carbon from the carbonyl. That's second part that you need to notice or pay attention to it. Second, the third, anything that is attached to carbonyl group will stay attached as the other 2 group. They will stay intact. So you have these 2 staying. So your R1 group is going to transfer over. The R2 group is going to transfer over. So if we call this one the R prime and then the hydrogen, so hydrogen would transfer, the R group is going to transfer, and the new bond that is forming is between the carbon, negatively charged carbon from Grignard and the positively charged carbon from carbonyl group. After you hydrolyze, you get secondary alcohol. Any questions? Just also, I'm testing to make sure that you can hear me. Do you have any questions?
No question.
Okay, perfect. So what happens if you add Grignard to ketone is that very similar mechanism again. For ketone, the only difference between a ketone and formaldehyde and aldehyde is that for formaldehyde, you have 2 hydrogen. For aldehyde, you have 1 alkyl group and 1 hydrogen. For ketone, you have 2 alkyl group. Now, when you add the Grignard, the carbon attached to the Grignard has negative charge, is acting as a nucleophile, is going to attack the carbonyl. Pi bond will break over the oxygen, you get the alkoxide. So in terms of the mechanism, I'm repeating, is the same thing. The only difference is that you are getting the new backbone of the molecule. You have your Grignard carbon chain is going to transfer to product. That's what is being boxed out here. So we have the R group that is coming. The new bond is forming between Grignard and the carbonyl group. Just repeating and paying attention that the new bond is forming between the carbon from the Grignard and the carbonyl. So that is the new bond forming. Anything that is attached to ketone as the second and the third alkyl group, if you take the alkyl group from Grignard as the first alkyl group, so this would be the second and third alkyl group, is going to stay connected to the same carbon that used to carry the double bond O. On the product, this carbon now carries OH bond. Okay, now it does carry the OH bond. So what else you want to know by heart? Like if you add Grignard to ketone, you would get tertiary alcohol. So the Grignard plus formaldehyde would give you primary, plus aldehyde would give you secondary, and plus ketone, it will give you tertiary alcohol. Let's say if you want to make this compound, you want to prepare this alcohol, what are using Grignard, and if you were trying to construct this or design an experiment to make this alcohol, what would be your first step is to find out what is this alcohol. This alcohol is a tertiary alcohol because it has carbon attached to 3 other carbon bond, so it's a tertiary alcohol. What do we know for preparation of tertiary alcohol? That we need RMGX plus ketone. So one of the R groups is coming from Grignard. Two of them is coming from ketone. So you have your choice. Now, it doesn't matter like which ones at this point. You have your choice. You can take the methyl group Grignard. You could take the ethyl group Grignard or the cyclopentyl group as a Grignard. We know that either one of them can give you the Grignard, but it doesn't matter which one you take. Just know that the other two is going to be the ketone. So let's say if we start with the CH3CH2 MgBr as a Grignard, that means I'm taking the ethyl group, this group coming from RMGX, and as a result, the other two should come from ketone. So basically, one of these is going to be the R, and the other one would be the R prime, and the other one would be the R double prime. So I have the CH3 and the cyclopentyl group that is attached. Now, if based on the inventory, basically, if you don't have this ketone, but you have the other ketone, so you can also choose the other ketone and take the different R group. But one R group is coming from Grignard, the other two R groups are coming from ketone. So these are the two other choices, like another choice for you. If you were going to use the methyl group as the Grignard, and then you get the different ketone, okay? And either one of them would take 2 steps. First of all, with the ether, this is going to change to alkoxide. In the solvent of ether, you heat it up for like 45 minutes, it changes to alkoxide. Then you hydrolyze and you add acidic water, you hydrolyze it, it changes to the alcohol that you want, a tertiary alcohol. Because you have Grignard plus ketone, it gives you tertiary alcohol. Grignard plus ketone, it would give you tertiary alcohol. This is the third option for you. Other carbonyl groups that can be reacted with the Grignard reagent is acid chloride. Now, what's the difference between acid chloride being added to Grignard or ketone being added to Grignard? I'm going to draw structure for a sample ketone. Let's say I have CH3 here and CH2CH3 on the other side. When the Grignard reagent attacks this ketone, okay, the weakest bond has to break. Do we have any leaving group in ketone? Alkyl group is not a good leaving group. So none of them is leaving group. So we have no leaving group here. There is no other choice but breaking the pi bond. So we break the pi bond, the pi bond breaks over the oxygen, and you get alkoxide. When the alkyl group from the Grignard attacks acid chloride, we do have a leaving group. So this is going to leave. Okay, when it does leave, we end up with what's going to happen if this leaves. You have an intermediate, and the intermediate that you get is going to be R. New bond between R and the carbonyl is going to form. So you get R, CO double bond, and then the R prime. So that would be your intermediate, the first step. And if we have ketone, we know that ketone plus Grignard is going to give us tertiary alcohol. That's why you are using 2 moles of Grignard in this case. The first mole is going to change the alkyl halide to ketone. And since Grignard and ketone reacts right away, the second mole of that is going to change the ketone to tertiary alcohol. But overall reaction, 2 moles of Grignard with acid chloride would give you tertiary alcohol. Now, the other product, or reactant of carbonyl group that can react with Grignard is ester. So if you have ester, what's going to happen? You have to check ester functional group, or the ester compound that you have for leaving group. Do we have any leaving group here? OR is better leaving group. Okay, OR is much better leaving group than the alkyl group. So OR is actually count as a leaving group. Since we have a leaving group, similar mechanism is going to happen. The first thing, nucleophile is going to attack the carbonyl group. Since there is a leaving group would leave. And as soon as the leaving group leaves, this is basically substitution reaction. So R is going to replace the leaving group. So you end up with a ketone. And since you end up with ketone and you still have Grignard reagent in the reaction mixture, the second mole of Grignard, so second mole of MgX is going to react with the ketone, and it gives you tertiary alcohol. So 2 moles of Grignard with acid chloride or 2 moles of Grignard with the ester would give you tertiary alcohol. So far we have 3 methods to prepare tertiary alcohol using Grignard. Grignard plus ketone, Grignard plus acid chloride, or 2 more, be more specific, 2 moles of Grignard with acid chloride and 2 moles of Grignard with ester. All 3 reactions would give you a tertiary alcohol. So if you're using Grignard, what are the next step here? In the first step, Grignard would attack the acid chloride, the leaving group would leave, and you end up with a ketone. And the next step, second mole of Grignard. So if you indicate this as the second mole of Grignard, it's probably be more, it does say second molecule. So this is the second mole of Grignard is going to attack the ketone, and it gives you tertiary alcohol. The alkoxide, you have to protonate it or hydrolyze it in order to get the tertiary alcohol. For ethylene oxide or epoxide, if you add Grignard, because we are looking for carbon with the positive charge, of course, this carbon with the positive charge, if it's attached to oxygen, it is positive charge. So it's another candidate to react with the Grignard. So far we had the CX, we had the CO double bond, and we have a epoxide, okay, plus the Grignard So RMGX can react with either one of them, and it can give you different products, okay? Different products. So what happens if you get ethylene oxide? If it's unsubstituted ethylene oxide, that means it's pure ethylene oxide. So there is really no R group attached. You have 2 hydrogen here, 2 hydrogen on the other carbon. This is unsubstituted ethylene oxide. If it's unsubstituted ethylene oxide, we get the nucleophile attacking one of these 2 carbons. And because there's a triangle, and the triangle, the bond angle is 60 degree, hybridization is sp3, which is supposed to be 109.5. So this is expected, and that's actually what it is, 60 degree. It's going under angle strain and is not stable. So it's very easy for this triangle to break. So oxygen breaks over the other carbon. So if the new bond forms between Grignard and the first carbon, oxygen breaks over the other carbon. You get the net result is, if you have Grignard, and I'm going to emphasize, if it's unsubstituted ethylene oxide, or it's just the ethylene oxide, there is no carbon attached to the ring. You have 2 carbon part of the ring, but there is no carbon attached to the ring, you will get primary alcohol. What's the difference between getting primary alcohol from adding ethylene oxide or formaldehyde? With the formaldehyde, you get addition of 1 carbon. When you add ethylene oxide, you would get addition of 2 carbons. So we have the R group here and 2 carbon coming from ethylene oxide. So if you have a Grignard reaction, or Grignard reagent with 4 carbon here, the product is going to have Grignard with 6 carbon. So the product is primary alcohol. So 2 indication. Grignard plus ethylene oxide is going to give you primary, okay? Then is going to be addition of 2 carbon. So these are the 2 points that you have to remember, because you already know how Grignard attacks formaldehyde. So the difference is that here you are getting addition of 2 carbon. You start with 4 carbon Grignard and you get 6 carbon primary alcohol. Epoxide, ethylene oxide, oxyran, they are all the same thing. Okay. What happens if you add water to Grignard? It would destroy the Grignard. It would give you the alkane and then a precipitate. That's what we are very concerned about. You don't want to have water until you're done with your reaction. Okay. Same thing. Water can destroy the alkyl lithium. It would change to alkane, and then you would get the byproduct. So the main thing is that your nucleophile is going to be destroyed. It's not nucleophile anymore. Okay, so your nucleophile changes to no nucleophile or not nucleophile. The other functional groups that I already said earlier, you have to be careful also, is that is presence of SH, NH. These are all ionizable hydrogen, or OH. So that counts for water, alcohol, amine, and thiols, or terminal alkyne. You cannot make it react with the Grignard. So, the CN, double bond, triple bond, SO, and NO, these are the other multiple bonds that it can react. Okay. Let's look at the other methods for preparation of alcohols. Other method is reduction of the alcohol. So if a reduction to alcohol. So if you have, so with that, we are going to talk about what is reduction one more time in organic chemistry. Reduction is adding 2 hydrogens. That's reduction. Okay. Oxidation is removing 2 hydrogens, or oxidation is adding bond, oxygen bond. So you're adding oxygen bond, that is oxidation. So if you want to remove, or if you want to go from aldehyde to alcohol, the structure for aldehyde, I'm going to just use an example here, COH. We need to add hydrogen. So we cannot just use H2, is not going to work because this is a carbon with a positive center. We learned that if you bring a nucleophile, it can react. So the reagent that is used here is actually sodium borohydride. Sodium borohydride, if you look at the name, it gives you hydride. And what is hydride? Hydride is H minus. This is the hydride. So basically the H minus from this, which is the active ingredient, is going to attack the carbonyl group. The pi bond will break over the oxygen. And then you would protonate. So as a net result, you would have CH3, CH2, COH. As a net result, you're going to have addition of 1 hydrogen. You have a negative charge here. On the next step, when you protonate this, you would get H. So you added hydrogen and another hydrogen. That falls under definition of reduction. Reduction of aldehyde. So first of all, you need to know what is reduction, is adding 2 hydrogen. Second, you need to know what reagent can you use. Sodium borohydride. It's good for this reduction. So you're adding sodium borohydride. The other reagent that you have is the LAH, or lithium aluminum hydride. This is strong, and this one is weak, reducing agent, or mild, okay, or mild. So because it's mild and is not very strong, it's safer to work with. So why would you use lithium aluminum hydride? You would use lithium aluminum hydride if you were dealing with carboxylic acid or carboxylic acid derivative. So for this one, you have to use lithium aluminum hydride for ester, for carboxylic acid, acid chlorides. But if you're dealing with aldehyde or ketone, sodium borohydride would be perfect. So definition for reduction is adding 2 hydrogen. The reagent that you are using for reduction is sodium borohydride. The reactant is aldehyde. Product is primary alcohol, and you want to pay attention to that. If the reactant is ketone, then the product is going to be secondary alcohol. So in this case, your reactant is a ketone. The product is going to be secondary alcohol after protonation. So first step, you always get the alkoxide when you bring the nucleophile. Next step, you protonate and you get your secondary alcohol. That's another method of preparation for alcohol. So we have learned about preparation of primary alcohol, 3 different ways. I'm just reviewing. That's Grignard plus formaldehyde, Grignard plus ethylene oxide, and third one is reduction of aldehyde. There are others to come, but at least you have learned 3 different ways. For preparation of secondary alcohol, one is Grignard plus aldehyde, and the second one is the reduction of ketone. So we have these methods to prepare different alcohols. Another method to prepare a primary alcohol is to reduce ester or acid chloride. But for ester or acid chloride, you must use a stronger reducing agent, which is the lithium aluminum hydride. If you use sodium borohydride with this, there would be no reaction. Okay, no reaction with sodium borohydride if you add sodium borohydride, because it's not strong enough. Okay, this is weak, and because it's weak, there would be no reaction. But if you add LAH, it would reduce all acid derivative, would go to primary alcohol. Okay, so sodium borohydride, it can reduce aldehydes and ketones. Lithium aluminum hydride, it can reduce aldehyde, ketone, ester, and any acid and ion. These are harder to, acid is harder to reduce compared to ester. The easier one to reduce is aldehyde, and that's why you don't need to use a strong reducing agent. You would use a mild reducing agent. Mild reducing agent is going to be easier to use, to consume in the lab, because it's not highly exothermic, and it's the reaction is more smooth. And if you can do the job, you would use that. So just pay attention that only lithium aluminum hydride would reduce ester and carboxylic acid to primary alcohol. Okay, examples that we have: cyclohexane carbaldehyde. So this is the aldehyde with sodium borohydride. It gives you primary, okay, primary alcohol. You have a ketone with sodium borohydride. It gives you secondary alcohol. You have ester functional group on this side, ketone functional group on the left side. When you add sodium borohydride, only ketone would reduce to alcohol, but ester would stay no change. This is the part that I was saying there would be no reaction if you add sodium borohydride to ester. But since this compound, your reactant, had both ketone and ester, ketone would be reduced, but ester will not be reduced. For lithium, if you add lithium aluminum hydride, both ester and ketone would be reduced. And I think this is exam question on the final exam as well. Okay. When would you use hydrogen versus sodium borohydride? If you use hydrogen with ranitidine nickel, this is a strong reducing agent, and that is going to destroy all double bonds. It would saturate. And if you care for this double bond, you want to maintain the double bond, you cannot use H2. H2 would reduce aldehyde and ketone. At the same time, it would reduce the carbon-carbon double bond and triple bond. If you care for the double bond, you want to keep the double bond, you're going to use sodium borohydride. Sodium borohydride, it will keep the double bond, but it will reduce the aldehyde to primary alcohol. So these are some of the points that you want to make sure you pay attention to it, so you don't, it doesn't take too much time to answer multiple choice questions. The difference between, first of all, you have to have a list of all reducing agents. Second, you want to know which one is specifically used under what condition. Okay, in preparation of the thiols, I usually don't cover this, but since we just want to look at what the thiol is, oxygen and sulfur, they are both in group 6 of the periodic table. The SH as a nucleophile, of SH minus as a nucleophile. It can attack alkyl halide. And if you use this as a nucleophile, the substitution reaction with the alkyl halide can change to thiol. Thiols are more acidic than the alcohol because of the size of the sulfur. Sulfur is larger in size compared to the alcohol. So this is like a SN2 type reaction. So it works best with the primary alkyl halide. If it's SN2 type reaction, primary alkyl halide would be the best candidate. For this, secondary would be just a slow reaction. We don't want to start with the what I'm looking for.